right, we're going to take a look at another specialty formula. Again, these things have kind of been outdated a little bit here, but this is a trig curriculum, so we'll take a look. Next thing we're going to take a look at here is called the power reducing formulas. I've taught trig at college a number of times. This is not typically an emphasis in, well, at two different universities, not typically an emphasis at either curriculum. But again, we'll cover it here. And the idea is this, that we would want to get down from a squared version of a sine trig function. So I've got, or any of our trig functions. I've got sine squared, cosine squared, tangent squared. I want to eliminate the square so I could just work with angles that don't have a square in it. Honestly, in the real world, I don't know why you would need to do this, but suppose it needed to be done. So the idea comes from all of these formulas are just derived from different versions of the double angle formulas. They're just the double angle formulas that are being rearranged. So if you take a look here, I've got one of the cosine 2 theta, and it's just been rearranged to prove that we can get sine squared turning into this. So similar method, we derive all of them. Now, again, I would give these on your formula sheet. I don't know really much to say other than they all turn into versions of cosine, which is notable. Let's take a look at how to use them here. So they start off with some, I would have preferred some just basic uses of this, but we've dove right into some more complicated uses that are more like identities. So the first thing they want us to see is that we want to get cosine of 4x to, what are they saying? Yeah, they want to get rid of all the exponents. So what we're doing here is we could see that couldn't you write cosine to the fourth power as this, cosine squared x all squared. Now we're going to use that power reducing formula here to turn what's inside the parentheses into this. Now notice that you take the original angle, remember x would represent an angle here, and we're going to double it. So that's a big part of the formula, or else you will get the questions wrong. Okay, so now we have this and we have it squared, just because we had started with x to the fourth. This isn't part of the formula. We just had taken this, power reduced it here, and now we're squaring it. Now, don't forget that if you had a fraction to an exponent, that's the same thing as 2 squared over 3 squared. You could square the top and the bottom, and that's what we're going to do here. So, do you see the bottom? If you squared the bottom, you'd have 2 squared, which is 4, and we've just moved this out front, so we can just leave it till the end. So 2 squared was 4. Now, if we square the top, this is the same thing as if you were squaring this. It's that same pattern. It's a binomial that we're going to repeat. And when that happens, you always get the first one squared plus 2 times the individual ones multiplied and the back one squared. If you don't remember that pattern, just be sure to just FOIL it out. You'll get the same thing. It isn't required that you memorize that. Okay, so we've gotten down to this line right here. Now all we need to do, they distributed the 1/4, and we have gotten, oh no, I'm sorry, not yet. We have another chance to do the power reducing formula here. So we have cosine squared of 2x. Let's use the power reducing formula one more time. Now notice it's going to double this angle, and this angle is now 2x. So our new angle is going to double that. It's going to wind up being 4x. Okay, so they have used the power reducing formula one more time, and they sent the 1/4 back through and just tidied things up a little bit. Oh yeah. This would be tricky here. I'll show you on another one here. But this 1/4 and the 1/2, just be sure you see how that would go through. That'd be like 1/2 plus cosine 4x all over 2. It'd be how you could think of this. So look, it would go here. That's where they got this extra 1/8. It would go here, and that's where they got another 1/8 cosine of 4x. Then finally, they just tidied up all the like terms, and that's how we got to our last step. Okay, so they want the power reducing formula to prove an identity. So first thing we're going to do here is I'm going to work on this side. This side over here doesn't look very pleasant. I guess you could look at this and say, hey, some algebra could be done here. But I don't see a good direction forward with that. So let's try this. Let's suppose that instead of sine to the third power, we wrote it like this. Wouldn't this be the same thing? So this is 3 sines of 2x's. If I multiply them back together, isn't this the same thing as to the third power? Now, why would I choose to do that? Because this one right here can use the power reducing formula. So, and what I like about it is it's going to turn a sine into cosine, and our identity here has to have both a sine and a cosine. So I reduced this using the power reducing formula. Now I think that's all I had to do. Yeah, the only thing we have to do is take out this 1/2. So let me show you. So if there's a 2 on the bottom, isn't that the same as a 1/2 being multiplied by the same thing? If I multiplied this 1/2 back through, it's going to become 1 cosine of 4x all over 2. It's the same. So I've just pulled that 1/2 out front. These are equivalent. Same thing. So they pulled it out front, then actually they just moved it all the way out front, and we're really got the same 3 things. We've got the 1/2 sine of 2x, the 1 minus cosine of 4x. The only thing here, again, remember, this original angle is 2x. I know it's weird, but the power reducing formula is going to double that. So if we double 2x, it becomes 4x. Okay, now we have a really odd one here. We've got an identity. We're going to use the power reducing formula to turn this into all of this. So let's get started. Obviously, I'm going to work with the left because I don't know what I would do with that right. So I'm going to pull out a 10. Just leave it sitting in front. And I'm going to turn this into cosine squared x all squared. Isn't that the same thing? Power to a power, you'd multiply those. Now the reason I'm doing this is because this will allow me to use the power reducing formula. So what I'm going to get next, cosine is plus, isn't it? Hold on. Yeah, 1 plus cosine of 2x. Okay, so I did this so that I could use the power reducing formula on here. Now, I've got it reduced. I've done the power reducing, but I have it to the second power. So what I'm going to need to do now, yeah, want to double check something. Yeah, so remember, like in the last one, if I have a fraction, this is all a fraction being squared. I can square the top and I can square the bottom. So the bottom is going to be 4. Do you agree with that? And I'm going to move it out front. So I'm going to put that 4 out here just to get him out of the way. Now I could reduce that. I'll do that on another step. Now I'm going to multiply 1 plus cosine of 2x. I'm going to square the top. And that's the same thing. We're really foiling. But the shortcut is going to be so I have foiled this. I did 1 plus cosine of 2x times 1 plus cosine of 2x. I just knew the shortcut. But if you don't know it, you'd FOIL that out. Okay, so far so good. We're starting to resemble something that looks like this right side. Now, what I'm looking at here is I see I've got another chance to do the power reducing formula. So if you look at our right side, there are no squares. So I know that I have to get rid of all the squares. Now I'm going to jump over here and make this 5 over 2. 1 plus 2 cosine. Okay, now we're going to do the power reducing again. So I've got 1 plus cosine. Now it's doubling the angle now, and now this angle is 2x. So this will now become 4x all over 2. Okay, I'm going to do it like this. No. I know what I do. Okay, this is over 2. There's a couple ways I can handle this. I'm going to just turn everything here. No, I don't think that's the best way to do it. I think that's unnecessarily complicated. Okay, so what I'm going to do here is I'm going to pull a 1/2 out of this. So we saw this trick before. If there's a 2 down there, he's really like a 1/2 in the front. Now, I'm going to distribute this 5 halves all the way through here. So I'm sending him to everybody. Now when he gets to this last group, he only needs to go to the 1/2 to be done. So he's going to come here and it's going to be 5/4. Because that last group needs a 5/2, but it gets it if it multiplies by this 1/2, because the 1/2 will then need to go through. I hope that makes sense. I've sent it to each of them. He only needs to go to that 1/2. Okay, so let's tidy this up. We've got 5/2 plus 5 cosine 2x. Now this is going to go through, so I'm going to have 5/4 plus 5/4 cosine 4x. Now let's just combine like terms here. This would be the same. So if I had 5/2 plus 5/4, so I've got two numbers that can just be combined. This would be the same as 10/4 plus 5/4. So I've got 15/4 plus 5 cosine 2x plus 5/4 cosine of 4x. And I've got what I needed. I don't need that. Okay, I've got what I needed. It's a match. So if you're like, where did this strategy come from? Basically, I just knew that we just had to keep power reducing, because if I look at the right here, there are no squares. And so you can be a little suspicious here when it turned into 4x that this must have been repeated uses of the power reducing formula, and it was. So after that, it really is just the power reducing formula and then some algebra multiplication. I know that's tricky, but if you need to see this, walk through this one again. Again, I don't put a big emphasis on the power reducing formula because the curriculums I've seen at college haven't done that either. But there it is, and we will work some problems, at least a few problems about it in this section.